Welcome to an Algebra 2 video on graphing a quadratic function. Sam, put your phone away. All right, so we're going to talk about finding the x-intercepts and finding the line of symmetry and finding the vertex. And what else do I ask for? The y-intercept and the symmetric point, right? So a lot of stuff going into graphing each of these. All right, so the first thing we'll do is find x-intercepts, all right? So for the x-intercepts, we always set y equals 0, right? You let y equal 0, and you got to solve this equation, right? And we're solving a quadratic equation, so we do that by factoring, all right? So you got to know how to factor to find the x-intercepts. So that's kind of probably the hardest part of the whole problem is the factoring part, because factoring is not an easy skill. All right, so to factor, we just make two sets of parentheses here, and we fill them in such that foiling works, right? Works backwards. So to make the x squared happen, we have x times x, right? And then the second two numbers have to multiply to 8. So we're not sure what they're going to be. It could be 8 and 1. It could be 4 and 2. We don't quite know yet. It ends up being 4 and 2 because the outsides, when you're foiling, okay, this is going to be x squared, right? X times x, and this is going to be 8. But from the outsides, we have 2x, and the inside we have 4x, right? And 2x and 4x can make negative 6x. If these are both negative, if you have the negative 4x and a negative 2x, they would make negative 6x. So with factoring, it might take you more than one guess, but in this time, I've been doing this for long enough that I know that's how it's going to work out. You can always just FOIL, check your work, but those are the correct factors. Right? What's a little bit different than just factoring, though, is we've got to write our solutions. So once you know the two factors, if this factor times that factor equals 0, right, that means that if you're multiplying two things to get 0, one of them has got to be 0, right? If a times b equals 0, then either a is 0 or b is 0. So you don't need to show this work, but if you want to show work, you would set each factor equal to 0 and solve those little equations, right? So this one, what would you do to both sides to solve for x? Add 4, right? And this one, you add the 2. These are our x-intercepts, and we're done. All right, so to find the x-intercepts, you let y equal 0, and then you factor. And then once you have it factored, you set each factor equal to 0, and you solve it. You don't need to show this work. Some of you guys will be able to know, okay, positive 4 for x would make this factor 0. Positive 2 would make that factor 0. Right? You don't have to show the work. And it always will be the opposite sign. Right, so this was a minus 4, and the solution was x equals positive 4. That will always be the case, all right? So far we have our x-intercepts. They are 4 and 2, or you can write them as ordered pairs, right? Because it comes down to it, we're making a graph, right? So on your graph, you already know that point will be an x-intercept and that point, where x is 2. So 2, 0, and 4, 0 are both going to be points on our graph, all right? So that's part of this. Knowing those two x-intercepts, we also can figure out the line of symmetry, right? I showed you a different way to find line of symmetry last time. Remember that formula, negative b over 2a? That's okay, but most people, when they're finding the line of symmetry, after you know your x-intercepts, because of symmetry, the line of symmetry is always going to happen halfway between them. So what's halfway between 2 and 4? 3. Right? So once you know your x-intercepts, halfway between will be your line of symmetry. So we went over the little formula for the line of symmetry last time. And I can show that to you again. I will show that to you again. But I think instead of dealing with the formula, you don't have to. Once you find your x-intercepts, halfway between them will be the line of symmetry. All right? So far, we've got a lot done already. Right? We found the x-intercepts, 4 and 2. We found the line of symmetry was x equals 3. Now the vertex is what comes next, right? So this is a lot of stuff to do. That's why this problem is kind of hard. For the vertex is an ordered pair, right? The vertex is going to be that low point or that high point on the graph, right? On a parabola, you have either a low point or you would have maybe a high point if the graph is flipped over, right? That point is called the vertex. You know that. So to find the vertex, it's going to be an ordered pair. Always going to be an ordered pair. We already know the x value. What is the x value of the vertex going to be? You can call it out. 3. Right? We know it's going to be 3 because we know the vertex lies somewhere along the line of symmetry, right? So the x value is going to be 3. So that you got to remember, right? Once you got to find the line of symmetry first, right? Because then you know the x value. Now, if you know x is 3, to find y, you just plug in 3, right? Plug in whatever number the x value is for the line of symmetry. So a little side note here, we're going to plug in 3. We get 3 squared minus 6 times 3 plus 8. And 3 squared, 9. 6 times 3 is 18. So 9 minus 18 plus 8. And that equals, I think, negative 1. Right? So 9 minus 18 plus 8. 9 minus 18 is negative 9, plus 8 is negative 1. So the vertex, our answer for the vertex, which you should have on your paper, is 3 comma negative 1. All right, 3 comma negative 1. The vertex is somewhere along this dotted line. It happens right there at 3 negative 1. All right, so this ordered pair, 3 negative 1, is our vertex. All right? So pretty much we know how the graph's going to look. It's going to be a parabola, right? It's going to open like this. But just to make it a little more accurate, I also ask you for the y-intercept and stuff, right? So far we've covered the x-intercepts by factoring, the vertex by just using symmetry, right? The vertex we figured out because of symmetry, the x is 3, plugged it in to find the y value. Now we got to do the y-intercept, right? So the y-intercept, remember this is what I said last time, the y-intercept is the easiest part of this problem. Because with the y-intercept, you plug in 0 for x. And what happens is, if x is 0, that's always going to wipe out those two terms, right? If x is 0, this goes away, and this goes away, and we're left with the y-intercept, which is 8. Right? So, yeah, I mean, you do plug in 0 for x, but you can kind of do that in your head. Because you know that those first two terms are going to wipe out. Any term with an x in it, if x is 0, is going to go away. So we get y equals 8. So now we know the y-intercept, right? The y-intercept is up here where y is 8 and x is 0. So at 0, 8, you put a point. That's the y-intercept. And by the way, just to be clear, you don't have to actually write these ordered pairs on the graph, right? Because you're given a grid, you don't have to actually write in the ordered pairs. And the last thing is the symmetric point. Right, so the symmetric point is talking about the point that's symmetric to the y-intercept. This point in particular, this point, you want to find on the other side of the line of symmetry. So somewhere out here is that symmetric point, right over there. You can do this by counting. Right? If the line of symmetry is at 3, or this line of symmetry was x equals 3, that means it's 3 units to get from the y-intercept to the line of symmetry. If this happens where x equals 3, right? This line is x equals 3. So you just count 3 more. 3 to here, so go 3 more, and you are at 6. 6 comma 8. So 6 comma 8 would be that symmetric point. All right, so symmetric point. You'd write as 6, 8. And then we're done. Then we have, enough points to graph. I mean, you can keep finding more and more points, if you want, but I think this is already a lot, right? To ask you for the x-intercepts and the vertex and the y-intercept and the symmetric point. This is a lot to do. But I just wanted to show you this, one more time, just so you had a video to a resource to check if you have some trouble. All right. So you have like 5 or 6 more problems. Thank you. All right. Yeah.